Hello friends, welcome to our channel Ullas Kumar Gokhale for Learning. The topic for today is Uninformed Search in AI Part 4, Depth First Iterative Deepening Search. So let us start with the agenda. First we'll discuss the depth first search, we'll take a review of that, and then we'll discuss the introduction to depth first iterative deepening. Then we'll discuss the DFID algorithm, then how it works. That is what we'll be discussing next. Then we'll take an example of DFID and try to illustrate that. Then next we discuss the properties of DFID, then advantages and disadvantages of DFID, and lastly we'll try to draw conclusion from that. So let us start with the depth first search review. So the depth first search always expands the deepest node in the current frontier of the search tree. So here the depth first search algorithm puts newly generated nodes in the front. Here they are put in the front of the open or fringe. When the newly generated nodes they are put in the front of the fringe, so that will result in expanding the deepest node first, because the newly generated node they are the deepest. So they will follow a last in first out order, and thus they are implemented using the stack data structure. So this is what we have seen in the last video. Now let us go to the introduction of the depth first iterative deepening. Here we are just having a variation of DFS, which we call it as the depth limited search, where we supply the depth first search with a predetermined depth limit and cut off the search at that depth. So this is what we have discussed in the last video. Now if we choose a limit beforehand, a solution may not be found at that depth. So this is the problem associated with the DLS. So for that we have another variation of depth first search, which we call it as the depth first iterative deepening search. So in this case what we do DFS up to a limit, and if we do not find a solution we increase the limit by 1 and continue the search. So that is the basic difference between the DLS and DFS. Then here, because of this iterative process, we'll find the solution and this will become the complete search. Then the DFID algorithm. So until a solution is found, do DFS, depth first search, with depth cutoff C. So if we don't find the solution, then C is equal to C plus 1, and we'll continue with the DFS. So this is the DFID algorithm. Then next, how it works. So here the idea is we do DFS up to a limit. If we don't get the solution, we increase the limit by 1 and continue. So until a solution is found, we have to do the DFS with depth cutoff C. Then C is equal to C plus 1. That is what we have seen in the algorithm. So the depth first iterative deepening is complete search, because we'll set the limit to 1, then to 2, then to 3, and then to 4, and so on. So the limit will be always incremented by 1 till we get the solution. So we are going to get the solution at the end. Then let us try to illustrate DFID with the example. So here we have the search tree starting with node A, then we have B, C, then D, E, then F, G, H, I, J, K, L, and M. These are the different nodes. So we'll try to put the limit one by one. First we'll put the limit 1, then 2, then 3, and then 4, and we'll try to do the depth first iterative deepening. This is a search tree. Now if we do iterative deepening search, A is the first node to be expanded. So if limit is equal to 1, so that is depth bound is equal to 1, so we get A, then we get B, and then we get C. So here depth bound 1 is completed. Then let us go to depth bound 2. Now here in this case, the limit is equal to 2. So node A is expanded and we get B. Then B is expanded, we get D. And then from D we get E. And then we get C. And then J. And finally we get K. So here the depth bound 2 is completed in this way. Then let us go to depth bound 3. So here the limit is set to 3. So again we start with node A, then we get B, then from B we get D, then from D we get F, then from F we get G, then from G we get E, then from E we get C, then we get J from here, and then we get K from here, and then we get L, and finally M. So this is depth bound 3. Then let us go to depth bound 4. So here the limit will be equal to 4. So we have a depth first search tree with depth bound equal to 4. So we'll get A, then B, then D, then F, then from F we go to G, then we get H, then we get I, then from I we go to E, then from E we go to C, then we get J, then we get K from here, and then we go to L, and finally we get M. So in this way the depth bound 4 it will be completed. So this is the iterative deepening search. Now we'll see the properties of the depth first iterative deepening. The first property is completeness. So because of the iterative deepening, the search becomes complete. Then optimality. So the search is optimal if all the operators have the same cost. But if the cost is different, then it will not be optimal, but it will guarantee that it will find the solution of the shortest path, just like the breadth first search. Then the next property is time complexity. Now the time complexity is little worse than BFS or DFS, because here the nodes near the top of the search tree are generated multiple times because of backtracking, and here almost all the nodes are near the bottom of the tree. The worst case time complexity is still exponential, that is of the order of B raised to D. Then if the branching factor is B and the solution is at depth D, then finally we are going to say the depth at D are generated once, then depth at D minus 1 are generated twice, etc. And if we take the sum of that, we'll get B raised to D divided by 1 minus 1 upon B square. So ultimately it will be of the order of B raised to D. So that will be the time complexity. Then the space complexity. So it is having a linear space complexity of the order B multiplied by D, just like the depth first search. Then advantages and disadvantages. So it has the linear memory requirements of depth first search, and it guarantees for the goal node of minimum depth. So these are the two advantages. And the disadvantages, the time complexity is little worse than the breadth first search, because here we have to expand some of the nodes repeatedly. That's why the time complexity is worse. That is the disadvantage. Then let us come to the conclusion. So this depth first iterative deepening combines the advantage of breadth first search, that is completeness, with the advantage of depth first search, that is limited space and finds longer paths more quickly. So because of these two advantages combination, this algorithm is generally preferred for large state spaces where the solution depth is unknown. So that is why this is the most preferred search for that. So with this we come to the end of the video. If you have any questions, you can contact me on Facebook Twitter, Gmail, or Instagram. Then if you like the video, press the like button, share with your friends, and subscribe to our channel Ullas Kumar Gokhale. And don't forget to press the bell icon so that you get notifications for future videos on this subject. And thanks for watching. Have a nice day.